So the electrical conditions are now back to normal, right? So after depolarization, repolarization, hyperpolarization, now we're back to negative inside, positive outside. We're back to that resting state. But the ions are in the wrong spot, right? Because remember, sodium rushed in and then potassium rushed out. What does that mean? Well, we're reversed. Remember our circle K? The electrical conditions are back to normal, the positives and negatives, but the ions are in the wrong spot. So what this is saying here, I'm going back to my pointer, after repolarization, well then that sodium-potassium pump will restore the ion conditions, the ionic conditions. So the sodium-potassium pump will then start pumping 3 out for 2 in, right? 3 sodiums out for 2 potassiums in. So the electric conditions reset first, and then the ion conditions take a few more split seconds to get back to their regular concentrations inside and outside the cell. An important point, so it's given its own slide, even though there's not a lot of information here, but it's important information when we're talking about an action potential, AP, this action potential, the all or none phenomenon. Action potential either happens completely or it doesn't happen at all, meaning it begins at the axon hillock, and if it begins, it's going to go all the way to the axon terminal, and either it does that or it doesn't start at all to begin with. That's different from a graded potential. A graded potential will start and then weaken and fizzle away, but an action potential is like dominoes. Once you hit the first domino, they're all going to fall right all the way to the end.